how to find the greatest common factor. There are two ways. The first way, way one, is by listing all the factors. So if I wanted to find all the factors of 12, I would say to myself, okay, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Now I want to list all the factors of 42. And this is a little more challenging because the number is a little bit larger. So 1 times 42 equals 42. 2 times 21, those are both factors, multiplied gives you 42. 3 and 14, 3 times 14. And 6 times 7. So when I look at all the factors here, what is the greatest common factor that they have in common? It happens to be the 6. The other way I can find out the greatest common factor is by using the factor tree. So we're going to factor 12. So let's take a look at 12, and we have, I can do 3 times 4. 3 is prime. 2 times 2. Now that all these numbers are prime. 3 times 2 times 2. And if we factor 42 using the factor tree, we have 6 times 7. 7 is prime. And then we have 2 times 3. Bring down the 7 so I don't forget that. So what do they have in common? They have a 3 in common, and they have a 2 in common. So then what I'm going to do is just multiply what they have in common. 2 times 3 equals 6. And this 6 is the same 6 if you list them using factors. Let's try these two numbers. I'm going to find the greatest common factor. So the two numbers will be 32 and 40. The first way we can find what the greatest common factor is by actually finding out the factors. So 1 times 32 equals 32. 2 times 16 equals 32. And 4 times 8 equals 32. For the number 32, oops, I just did that. For the number 40, the 1 times 40 is 40. 2 times 20 equals 40. 4 times 10 equals 20, or 40, sorry. And 5 times 8 equals 40. What's the greatest common factor? 8. Now we can do it using prime factorization. So let's take a look at it that way. 32. So we'll use the factor tree. We have 4 times 8. And then 4, we can bring that to two factors of 2 times 2. And then 8, 2 times 4. So the 2's are prime. Now we can bring the 4, change that to 2 times 2. So we have 1, 2, 3, 4, 5 2's. So there'll be 2 to the 5th power. For the number 40, we'll turn that into a factor tree there. We'll do 5 times 8. 5 is already prime. 8, we'll say 2 times 4. 4, we can factor down to 2 times 2. So let's bring this 5 down to 2 down. So we have 5 times 2 times 2 times 2, which would be 2 to the 3rd power. What do they have in common? They each have 3 2's. So that would be 2 to the 3rd power, which is the same thing as 2 times 2 times 2. 2 times 2 is 4, times 2 equals 8. So the greatest common factor is 8. All right, so let's find the greatest common factor for 10 and 24. First way we're going to do it, way one, is we're going to list the factors. So we'll find the factors that create 10. 1 and 10, and 2 and 5 are the factors that create the number 10. And we'll take a look at the number 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6 equals 24. The greatest factor that they have in common is the 2. So now let's break this down using prime factorization. And I'm going to use the board over here since I didn't use that much space over here. We'll take the number 10, 2 times 5. And those end up being prime numbers, and that gives me the answer of 10. 5 to 10, 24. Let's break down 24. 4 times 6. 4 can be broken down into the two prime numbers of 2 times 2. And 6, 2 times 3. So what do they have in common? And this is the problem that threw us off today because it was MRSC Monday. What do they have in common? They each have 1, 2 in common, and that's it. They also have, if you think about it, a 1 and a 10, and a 1 and a 24. So really you can kind of say 2 times 1. So what do they have in common? Is they have a 2.